Alright, welcome back to part 2 of section 8-2, factoring greatest common factor. So let's finish up the notes on example 3 and example 4. Alright, so example 3 and 4, you're doing the same exact thing as you do in example 1 and 2. But the only thing that they have extra is this last extra term over here. So instead of having 2 terms, you're going to have 3 terms. And when we factor polynomials, you'll most of the time you have 3 terms. You won't have it all the time, but we'll do 3 terms just so you'll get used to factoring 3 terms. So let's start out. Step number 1, we're going to find the greatest common factor by using the prime factorization. And this time we're going to do that to all 3 terms here. Alright, so 10. Factor 10. 2 number to multiply get you to 10 is 5 times 2. And I think that's it. 20. So 2 numbers that multiply to you to get to 20 is 5 times 4. 4 is not a prime number, so let's break that down one more time into 2 times 2. Alright, the last one, 5. Break 5 down. Only 2 numbers that we can multiply into 5 is 1 times 5. Alright, so that's it. So let's start listing these out and see what they have in common. So 10y cubed, that would equal to 5 times 2 times y times y times y. The next term, 20 y squared. We're going to end up having 5 times 2 times 2 times y times y. And then the fifth term, number 5, 5y, we'll have 5 times 1 times y. So as you can see, the only thing that we have in common is the 5 here, the y here, and I think that might be it. It's just the 5 and the y. So let's bring them down just so we can see them more clearly. So bring the 5 down since they have 5 in common. Multiply by the y. So our GCF is equal to 5y. Alright, step number 2. Step number 2, we are going to write the terms as a product by using the greatest common factor. So let's write this polynomial by taking this factor out. So 10y cubed, when we factor the 5y out, we're left with the 2 times the y and another y over here. So we're left with 2 times y, which is 2y squared. And we're going to multiply that by our greatest common factor, which is 5y. And then we're going to add that to the next term, and our next term is 20y squared. So when we factor the 5y out, we're left with the 2 times 2 and y at the end over here. So 2 times 2 is 4, times y is just y, and multiply that by our greatest common factor, which is 5y, plus our last term. So our last term was 5, oops, I made a mistake. Our last term was 5y. I also made a mistake down here. Let me erase this. So well, I can't erase that, but that should be a minus sign right here. So minus, and all we had left on the 5y is a 1. So 1 times 5y. Alright, step number 3. Step number 3 tells us to use the distributive property to factor out the GCF. So our GCF here is 5y. As you can see, each term has a 5y here. So we're going to distribute that out and leave the other terms inside of the parentheses. So factor out 5y and I'm going to put the parentheses around the rest of the terms. So we're going to multiply that by, that's 2y's the piece that's left on that part, 2y squared plus 4y minus 1. So as you can see, this is our complete factor form of our original function, original polynomial. And then the last step, we're going to check and see if our answer is correct by distributing the 5y back into these 3 terms. So step 4. So to distribute that back in, 5y times 2y squared, that would be 10y cubed. 5y times 4y, that would give us plus 20y squared. 5y times 1 will give us 5y. And as you can see, that's the same exact thing as what we started with. So by being able to factor this 5y out as the greatest common factor, that would be correct. Alright, again, I encourage you to do example 4 and then check with my work to see if we have the same answers. Alright, so hopefully you give that a shot. I know you're probably about 20 minutes into the video already. Alright, so I'm going to move a little faster in example 4 just so we can finish the example and you can start the work time on the work in Schoology. Alright, so example 4, we're going to factor out, we're going to find the greatest common factor by using the prime factorization. So let's factor out 8, 4, and 2. As you can see, all of these terms have all negatives in here. So when we factor, let's just factor the positive ones out and then factor the negative sign out at the end. So 8. 2 numbers and multiply to get you to 8 are 2 times 4. You can break 4 down to 2 times 2. 4, you can break 4 down into 2 times 2. And 2, you can break that down into 1 times 2. Alright, so let's list the factor out. Alright, so negative 8x to the 4th power would equal to 2 times 2 times 2 times x times x times x times x. 4 x's. Negative 4x cubed will be 2 times 2 times x times x times x. And negative 2x squared will equal to 1 times 2 times x times x. So the thing that they have in common here are the 2's, this x, and this x. So let's bring that down. So they have the 2 in common, they have the x in common multiplied by x, and they also have this x in common over here. If that green is kind of hard to see, let me highlight that with the black. I think it might be easier to see. 2 times x times x. So that will equal, so our GCF will equal to 2x squared. But remember, we mentioned earlier that we have a negative, and a negative in front of all the terms. And then at the end here, we're just going to factor that out because they all have negatives. So our greatest common factor would be negative 2x squared. So step 2, we're going to write the terms as a product by using the greatest common factor, factoring that out. So when we factor negative 2x squared out of 8x to the 4th power, we're left with 2 times the x. So we're left with 4x times our greatest common factor, which was negative 2x squared, plus, when we factor the negative 2x squared out, from the negative 4x cubed, we're left with the 2 and the x at the end here. So we're left with just 2x. And we are going to multiply that with our greatest common factor, which is negative 2x squared. And last but not least, our negative 2x squared term. So when we factor the negative 2x squared out, we're left with just a 1. So multiply that by 1. And I'm going to write this in red just because I can't see black on this back surface over here. Multiply that by our greatest common factor, which is a negative 2x squared. So it's a negative 2x squared if you can't see that on the side here. Actually, just let me rewrite that in the bottom here. So I'm going to scribble this out. Times negative 2x squared. Alright, so step number 3. We're going to use a distributive property to factor out our greatest common factor. So our greatest common factor here in each term is negative 2x squared. So I'm going to factor that out. Negative 2x squared. And when we do that, the first term, we're left with just a 4x times 4x plus 2x. Let me change my color really quick. Plus 2x, and then minus 1. So by factoring negative 2x squared out, we're left with negative 2x squared times the quantity of 4x. Again, I made a small mistake. I forgot there was 2x at the end here, so this should have been 4x squared. So we're left with negative 2x squared times the quantity of 4x squared plus 2x minus 1. And if we were to check and see if our answer is correct, step 4, you're going to distribute the negative 2x squared into all 3 terms. So negative 2x squared times 4x squared is a negative 8x to the 4th power. If you distribute negative 2x squared times 2x, that will give us a negative 4x cubed. And then lastly, negative 2x squared times a negative 1. I'm sorry, not a negative 1, it's supposed to be a positive 1. You will get negative 2x squared. So as you can see, our end result, when we distribute the negative 2x squared back into our quantity here, we get the same results as our beginning answer. So that shows us that yes, this is correct. Sorry for the many mistakes that I had. For example, for here I went kind of quick, and as you see, if you go kind of quick, you can make a lot of mistakes. So slow down. Again, the homework is on Schoology. If you have any question, ask me during work time or any time during the day. Thank you for watching the video, and have a great day.